I'm afraid I can't do the greeting in the proper language. I can do it in Australian Aboriginal if that helps, but I don't think that would really help you very much. So I'm going to give you a very quick march through sustainable development and a bit of climate change thrown in for good luck. This is a whole lecture course normally, so I've absorbed it into about 45 minutes, so it's going to be a bit brief and a bit skating over the top, but hopefully you'll get something out of it. So I'm going to start off with a little video clip, and this video clip only runs for about 10 seconds, so I'll run it a few times. The first thing, climate change isn't the same as sustainable development, so I'm going to say a little bit about climate change first, because it's one of the canaries in the coal mine that alerted us to the fact that the world needed to step up to create a sustainable future. And the question about climate change people always ask is, has the climate changed? Well, this little video just shows the temperature of the Earth from 1950 through to 2010. And it pulses in and out as you get hot years and cold years. And, but if it goes redder, then it's getting hotter. If it goes bluer, then it's getting colder. And so I think I'll let you make your own mind up as to what's happened over that time. And of course, since 2010, over the last 3 years in particular, we've seen every year has been successively the warmest year ever recorded. So I think it's fairly clear that the world has been warming. Climate change and sustainable development are not new. So the greenhouse effect was outlined by Fourier in 1827. So it's been around for a while. Most people think it's only happened since the Earth Summit in 1990, but it's actually been around a while. And John Tyndall was the first one to demonstrate experimentally how carbon dioxide absorbs the radiation at the wavelength at which it goes out of the Earth, and it's get absorbed by these so-called greenhouse gases in the atmosphere. And the more of those gases that there are in the atmosphere, the more of the outgoing heat gets absorbed, and hence we get global warming. And most first-year physics students still repeat that experiment, pretty much using apparatus which still looks very much like that, or at least in my case it did. The physics hasn't changed since 1881. And then Svante Arrhenius in 1896 was the first one to predict that this trapping of these gases in the atmosphere, doubling of carbon dioxide, will lead to about a 5-degree warming. And he didn't have any of the world's, these massive supercomputers that we use today to model all of the feedbacks between the ocean and the atmosphere and the land and the sea ice and so, the biosphere and so on. He did it all on a piece of paper, and he got an answer not too far distant from what we still estimate it to be today. And in fact, we actually have his girlfriend to thank for the fact that he did that calculation, because she dumped him. And he went into a sort of fit of depression and locked himself away for several years to do this calculation. So we've got his girlfriend to thank for the fact that she dumped him for doing this calculation. So what you really want to know is what's going to happen in the future. And so this is a projection. It's done from the Hadley Centre in the UK, which is the UK Government Research Centre into Climate Change. And what you can see is the year stepping forward there in the bottom right-hand corner. The temperature scale is along the bottom, and the Earth is rotating around. And you'll see that it says temperature rise for an A1B scenario. What the hell does that mean? So we don't know what the temperature change is going to be over the next 100 years, because it depends on how much of these greenhouse gases we emit into the atmosphere. So in order to make these projections, we don't call them predictions because we can't predict, we call them projections. We project if the world behaved like this, then the climate change would be like that. So this is a projection which is what we call a medium-low scenario, where the world continues to emit some greenhouse gases, but at a rate not quite as high as it is today. And what you can see is that as it goes round, you get blue pulses and red pulses. This is what we call interannual variability. The weather changes from day to day, week to week, year to year. But as we move further forward, you'll start to see, particularly up at the top, near the top, I've tilted this down so that hopefully you can see a little bit more about this part of the world. But you'll see, particularly in the northern high latitudes there, a considerable warming start to take place. And that's because the large land masses are largely in the northern hemisphere. The land masses warm up quicker than the oceans because the oceans act as a huge heat sink. Water is a very good absorber of heat. And so that tends to even out the temperature. And so as we get to the middle of the century, you can see all the major land masses are starting to warm up. By the second and third half of the century, then even the oceans are starting to turn a little bit sort of orangey and start to warm up as well. There'll still be the odd blue pulse you'll see there, so there'll still be some climate skeptic around in 2080 saying it was cold in Nepal last year, so it can't possibly be global warming. And then by the end of the century, As you can see, pretty much everywhere is warm, particularly those land masses. That's about an average global warming of about 3.5 degrees, which is a kind of mid-range estimate of what we might expect. I used to show a high emissions scenario where we continued to emit a lot of greenhouse gases, but the whole sort of world went black and people didn't like it. It kind of freaked them out a little bit, so I don't show that one anymore. So that's a little bit to show you that we have something of an issue around climate change. But climate change, that's very abstract in its numbers, if you like. And so what I've done here is I show this black line here shows the temperature in Northern Europe in Northern Europe, and each point is a year. So that's 2003. Why that arrow's moved, I'm not quite sure. So that's 2003, and what you can see is that the summer in Europe in 2003 was extraordinarily warm. It's estimated that over 40,000 people died as a result of the heat wave in Europe that year, and that's a very, very conservative estimate. And so we did the calculation, and what we said is, I wonder how unusual that summer is. So we ran the climate models, and of course we'd already emitted some greenhouse gases by 2003, but let's assume that we hadn't. So let's assume back at the beginning of the century, back in 1900, how likely would that summer have been? And it came out to be 1 in about 1,000 years. So it was 1 in 1,000-year summer. However, we ran it again with the greenhouse gases in, and by 2003 already, that became a 1 in a 200-year summer. So they were still really unlucky to get it. It was still only 1 in 200 years, but it was 5 times more likely than it would have been if we hadn't had global warming to that point. But then if you run the model out into the future, what you see is that by the 2040s that becomes an average summer, and by the 2060s that becomes an unusually cold summer. So that's just a way of trying to express, if you like, what climate change is going to feel like. And the other example I like to use is biodiversity loss. We're losing species on the planet today at a rate higher than at any other time in Earth's history, and that includes when the dinosaurs died out. We're in the middle of the 6th great mass extinction of species right now. And there's a natural rate at which species come into being and go out of existence, and that for mammals that's about 1 species in 1,000 every 1,000 years. And we're already at around about 1,000 times that background rate. That's not all due to climate change, that's due to invasive species, land degradation, the fact that we've cut down lots of forests and turned land over to agriculture, and as my biological colleague put it, we've killed everything larger than a sheep. But the prediction is because of climate change, that's going to increase by a further factor of 10, to a factor of 10,000 times the background rate of loss of species. And people have tried to do an estimate of how many of the world's species we're going to lose by the end of this century. And it's an extraordinarily difficult calculation to do because we don't even know how many species there are on the planet. We don't even have an inventory of all the species. We're finding new species all the time. So the estimates are a very broad range, but those estimates come in the range of something like 25 to 40%. So we're likely to lose, as a result of this, about 25 to 40% of all the species on the planet by the end of the century if we don't deal with this. So that's an entire lecture on climate change. Just to give you an idea of what it feels like, a colleague put together this talk. I've shown this graph for many years. So this shows the observed temperature change, and then this shows the projected temperature change if we don't mitigate our greenhouse gas emissions. In other words, if we don't decarbonize our economy. And this is what we're trying to achieve, a global warming of no more than 2 degrees. But to do that, we have to completely decarbonize by 2050. We have to reduce to much lower than it is today very, very quickly. But then what one of my colleagues did, rather cleverly, I thought, was to put herself on it. Well, so I've put myself on it. And this is very scary because the first thing you have to do is decide when you're going to die. So the temptation is to run this line all the way out here somewhere. But what I've done, I've been very good and being objective, and I've put the average life expectancy of someone of my age in. And so you can see that in my lifetime, I expect to see global temperatures move from about here to about here, which I think is pretty bad. But then I put my children on it, who were born in the late 1980s, and do their average life expectancy as well. And the climate change they can expect to see in their lifetime is from here up to about here, which is, an awful lot more than I will see in my lifetime. And then what I did, which is very controversial, is put my grandchildren, which are non-existent grandchildren. My children are 30 and 32, so it's about time that we're getting on with it, frankly. But when I did this slide, I thought, it's all right, my children are living back in the UK. They're both grown up and living in the UK, so they will never see this. So that's okay. And then my daughter came out to live in Australia for 18 months and saw me give this presentation, and I was in such trouble when I got home. But the point of the exercise is that the climate change that they could expect to see in their lifetime is from here, way up here somewhere. So that's what we're trying to avoid. So that's climate change in a nutshell. But if you thought climate change was bad, there are other threats to the planet, and they are embodied in threats to what we call sustainable development.
This is the story of how one species changed a planet. The latest chapter of our story begins in England 250 years ago. Fueled by coal, then oil, several brilliant inventions appeared. They ignited the Industrial Revolution, which spread like wildfire through Europe, North America, Japan, then elsewhere. The great railways, then cars and highways, connected people across the globe. Medical discoveries saved millions of lives. New artificial fertilizers meant we could feed more people. Population rose rapidly. But this was nothing compared with what was to come. The 1950s marked the beginning of the Great Acceleration. Globalization, marketing, tourism, and huge investments helped fuel enormous growth. People swarmed to cities, which became even more powerful engines of creativity. In a single lifetime, the well-being of millions has improved beyond measure. Health, wealth, security, longevity. Never have so many had so much. Yet 1 billion are malnourished. In a single lifetime, we have grown into a phenomenal global force. We move more sediment and rock annually than all natural processes, such as erosion and rivers. We manage 3/4 of all land outside the ice sheets. Greenhouse gas levels this high have not been seen for over 1 million years. Temperatures are increasing. We have made a hole in the ozone layer. We are losing biodiversity. Many of the world's deltas are sinking due to damming, mining, and other causes. Sea level is rising. Ocean acidification is a real threat. We are altering Earth's natural cycles. We have entered the Anthropocene, a new geological epoch dominated by humanity. This relentless pressure on our planet risks unprecedented destabilization. But our creativity, energy, and industry offer hope. We have shaped our past. We are shaping our present. We can shape our future. You and I are part of this story. We are the first generation to realize this new responsibility. As the population grows to 9 billion, we must find a safe operating space for humanity, for the sake of future generations. Welcome to the Anthropocene.
So what that says is that as human beings, we are now affecting the world's natural processes at a scale as large as or larger than those natural processes themselves. And so that we are now the dominant species on the planet. So the question then is, how do we try and create that safe operating space for humanity, that safe place on Earth where we can operate? So the first thing to look at is, well, how sustainable are we now? And I've picked out a few statistics here to say how is New Zealand doing? So the first thing is life expectancy at birth. And what you can see is New Zealand is there 4 up from the bottom, but it's still doing pretty well. Life expectancy of around about 83 years for a person born today. If you're a woman, that is. About 78 if you're a man. Incidentally, the difference between men and women is one of the smallest in New Zealand of any country. But compared to Japan, probably not doing as well as we could do. So Looking at secondary education, you can see that virtually all countries have improved the rates of attainment of secondary education. You can see New Zealand there, one below the OECD average. It's up there along with the kinds of percentages that most of the other developed countries are. The increase isn't quite as large because the attainment was already quite good even in the past. This is where New Zealand really scores extraordinarily highly. It is the highest in the world in terms of feeling safe of all the OECD countries in the world. You feel safer than any other people in the world. Doesn't that feel good? I wonder whether you are safer than all the other people in the world. Shall we have a look? Okay, this shows the incidence of personal crime, and I don't know whether you can see here. New Zealand sits here after Canada, Japan, USA, Poland, Israel, UK, Indonesia, Australia, Korea. So it's interesting to see that Australia is actually slightly, very, very, very slightly safer, whereas if you look at the perception, Australia is over there in the red. Australians feel really unsafe. I don't know whether it's the threat from you coming over, or, no, I won't go there. But you feel really safe. But in fact, we're about the same. So I thought that was interesting. In terms of protected areas, New Zealand is up towards the right, so that's pretty good, but then you are proud of the fact that you have lots of wild natural environment and a huge great ocean to protect, and so maybe it isn't quite such a good statistic as it might appear on the surface. And then in terms of municipal waste, and this is where, I actually haven't checked the statistics, so I'm going to actually have to turn to Marianne here and see. New Zealand appears to be the worst country in the world for waste to landfill. Your recycling rates are atrocious. I don't know why that is. Perhaps there is something behind that which we can discuss later. So anyway, so it's a mixed picture, as it is for every country you look at. There are some good, some bad, and so on. Climate change, nowhere near as bad as Australia in terms of greenhouse gas emissions per capita, but still nothing really to be very proud of. So again, as I say, a mixed bag. So what are we trying to achieve? We're trying to achieve sustainability, and there are lots of definitions of sustainability, lots of models of sustainability and sustainable development. The one that most people gravitate to is the definition by Brundtland, which is now quite old, and people are trying to rewrite it all the time. I've tried to rewrite it myself, but this one always seems to come back to. Sustainable development is the development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So that means let's live well today, but let's do so in a way that allows future generations to also live well. In other words, let's not screw it up for our kids, is a polite way of putting that. And most people, and that is now accepted as having three fundamental pillars: economic prosperity, social equality, social justice, and environmental protection. And if any one of those things, any one of those pillars falls down, then we don't have sustainability. So for example, if the environmental pillar falls down, then we can all be rich and that wealth can be shared equally, but we've got no planet to live on. It's not really great. We can have environment, so we can have a nice environment and a very socially equitable society, but we don't have enough money to buy food, then that's not very good either. And if we have a strong economy and a strong environment, but all of that wealth is centered in 3 people, and all the rest don't have anything, then again, that's not very good. So in other words, to provide sustainable development, we need all of these 3 pillars. And the argument is that this is exactly what's been happening, and that's what we're trying. That's what sustainability is trying to avoid. The first attempt to do this was the Millennium Development Goals. These were agreed in the year 2000. They ran to the year 2015, and they were really social goals, and they only applied to developing countries. So it was about poverty, hunger, education, health, and so on. There was number 7, ensure environmental sustainability, but nobody really paid any attention to that. And they actually had an impact. If you actually look, the last 15 years to 2015 was really the first time that we made major inroads into some of the major social issues facing the world. So in terms of extreme hunger, in other words, people living on poverty and hunger, the people living on less than $1.25 a day went from 47% in 1990 to 14% in 2015. That's massive. I mean, some would argue that that's nothing to do with the Millennium Development Goals, that's to do with rapid developments in China and so on, but whatever. Massive progress. In terms of universal primary education, from 52% in 1990, 60% in 2000, up to 80% in 2015. Again, massive strides made. Again, somewhat hides a few little gremlins there, because the target was to achieve universal primary education. It didn't say anything about the quality of that education. So some countries actually met that by opening schools and forcing kids to go, and then the kids just left home and there were no teachers and so on. So now the Sustainable Development Goals actually try and rectify that in terms of looking at quality of education. So the Millennium Development Goals, a mixed bag, but generally some really significant progress. But also the world went backwards in some areas, in terms of inequality, in terms of climate change and the environment, as I've just said, and in terms of conflict and refugees, and there are other areas as well. And I just want to do a little diversion just for a few minutes to talk about inequality, because that's one of the major transformational changes that we've seen take place over the last 20 years about the increase in inequality in the world. Now this is a little video, and so what I'm going to have to do, because the video doesn't run, I'm going to have to run it off.
There's a chart I saw recently that I can't get out of my head. A Harvard business professor and economist asked more than 5,000 Americans how they thought wealth was distributed in the United States. This is what they said they thought it was. Dividing the country into 5 rough groups of the top, bottom, and middle 3 20% groups, they asked people how they thought the wealth in this country was divided. Then he asked them what they thought was the ideal distribution. And 92%, that's at least 9 out of 10 of them, said it should be more like this. In other words, more equitable than they think it is. Now that fact is telling, admittedly, the notion that most Americans know that the system is already skewed unfairly. But what's most interesting to me is the reality compared to our perception. The ideal is as far removed from our perception of reality as the actual distribution is from what we think exists in this country. So ignore the ideal for a moment. Here's what we think it is again. And here is the actual distribution. Shockingly skewed. Not only do the bottom 20% and the next 20%, the bottom 40% of Americans barely have any of the wealth. I mean, it's hard to even see them on the chart. But the top 1% has more of the country's wealth than 9 out of 10 Americans believe the entire top 20% should have. Mind-blowing. But let's look at it another way, because I find this chart kind of difficult to wrap my head around. Instead, let's reduce the 311 million Americans to just a representative 100 people. Make it simple. Here they are: teachers, coaches, firefighters, construction workers, engineers, doctors, lawyers, some investment bankers, a CEO, maybe a celebrity or two. Now let's line them up according to their wealth. Poorest people on the left, wealthiest on the right, just a steady row of folks based on their net worth. We'll color code them like we did before based on which 20% quintile they fall into. Now let's reduce the total wealth of the United States, which was roughly $54 trillion in 2009, to this symbolic pile of cash. And let's distribute it among our 100 Americans. Well, here's socialism, all the wealth of the country distributed equally. We all know that won't work. We need to encourage people to work and work hard to achieve that good old American dream and keep our country moving forward. So, here's that ideal we asked everyone about. Something like this curve. This isn't too bad. We've got some incentive, as the wealthiest folks are now about 10 to 20 times better off than the poorest Americans. But hey, even the poor folks aren't actually poor, since the poverty line has stayed almost entirely off the chart. We have a super healthy middle class with a smooth transition into wealth. And yes, Republicans and Democrats alike chose this curve. 9 out of 10 people, 92%, said this was a nice, ideal distribution of America's wealth. But let's move on. This is what people think America's wealth distribution actually looks like. Not as equitable, clearly, but for me, even this still looks pretty great. Yes, the poorest 20 to 30% are starting to suffer quite a lot compared to the ideal, and the middle class is certainly struggling more than they were, while the rich and wealthy are making roughly 100 times that of the poorest Americans, and about 10 times that of the still healthy middle class. Sadly, this isn't even close to the reality. Here is the actual distribution of wealth in America. The poorest Americans don't even register. They're down to pocket change, and the middle class is barely distinguishable from the poor. In fact, even the rich between the top 10 and 20 percentile are worse off. Only the top 10% are better off. And how much better off? So much better off that the top 2 to 5% are actually off the chart at this scale. And the top 1%, this guy, well, his stack of money stretches 10 times higher than we can show. Here's his stack of cash, restacked, all by itself. This is the top 1% we've been hearing so much about. So much green in his pockets that I have to give him a whole new column of his own because he won't fit on my chart. 1% of America has 40% of all the nation's wealth. The bottom 80%, 8 out of every 10 people, or 80 out of these 100, only has 7% between them. And this has only gotten worse in the last 20 to 30 years. While the richest 1% take home almost a quarter of the national income today, in 1976, they took home only 9%.
I think he's made his point. So what you see there is that there's really quite an astonishing difference in terms of inequality. And that has just increased rapidly over the last 20 years. To the point that income inequality is now lopsided, that 8 men now own the same amount of wealth as the poorest half of the world. And the world's 10 biggest corporations together have a combined revenue greater than 180 of the poorest countries combined. And if you want to know who they are, those are the 8 men, and they are men, unfortunately. So, inequality is one of those things that has really stepped up. So in the Sustainable Development Goals, they set themselves an aspiration to continue the good work of the Millennium Development Goals, but also to do something else. And it said, we underscore that the Sustainable Development Goals should be action-oriented, concise, easy to communicate, limited in number, aspirational, global in nature, universally applicable to all countries, taking into account different national realities, capacities, levels of development, and respecting national policies and priorities. Yeah. And then tomorrow we'll do something really difficult. So trying to get 193 countries to agree that they tried for 3 years, over 1 million people contributed to online fora and so on, and that's what they came up with. Now, you could argue that they failed in their task, because that's hardly a small number, they're hardly concise, so they are by no means perfect. But I think it's absolutely, truly, and utterly remarkable to get all of the world's countries to agree on 17 Sustainable Development Goals, underpinned by 169 concrete targets around poverty, hunger, health, education, gender equality, clean water and sanitation, clean and affordable energy, decent work and economic growth, industry, innovation and infrastructure, reduced inequalities, sustainable cities and communities, responsible consumption and production, climate change, life below water, life on land, peace, justice and security, and partnerships for development. And it's really difficult when you actually put that down like that to see which ones you would actually throw out, which ones are those you don't want. And after all, we've managed to remember 10 commandments for about the last 2,000 years. So maybe 17 Sustainable Development Goals is not too far out of our ability. So that's what we have. There are some critical differences between, so these are just some of the targets listed underneath. There's some critical differences between these and the Millennium Development Goals. It integrates the 3 pillars of sustainable development. You saw things there about jobs, about environment, and about social issues. But the crucial thing is that they apply to all countries. So they apply to New Zealand as well as to Burkina Faso. It's a plan of action for people, planet, and prosperity, those 3 pillars. It says we are resolved to free the human race from the tyranny of poverty and want, and to heal and secure our planet. So this is now not trying to reduce poverty, reduce hunger, this is trying to eliminate it. This is over a 15-year period. It says we want to be bold and transformative, and as we embark on the collective journey, we pledge that no one will be left behind. And that's really critical. And that's one thing that a lot of the developing countries have really grasped, is that this is about everyone, not just about that richest 1%. So why are SDGs useful? Why is goal setting useful? Because it sets benchmarks for government. Government like targets. They like ignoring them and avoiding them when they can't meet them, but they like targets. At least they like to know where they're going. It mobilizes the community. So if you look at all of the aid agencies around the World Bank, the Gates Foundation, all of the major charities and so on, they're all now focusing around the Sustainable Development Goals. If you look at a lot of the countries, they are now focusing on the Sustainable Development Goals. Countries from as disparate as Germany and Colombia have set up ministries for the Sustainable Development Goals, which sit over all of the other ministries. Japan have set up an intergovernmental committee which sits again above all the other ministries in order to achieve the Sustainable Development Goals. So it mobilizes the community. It mobilizes partnerships. If you notice that this was, what I said in here, all countries and all stakeholders acting in collaborative partnership will implement the plan. So this isn't just about governments. This is about mobilizing partnerships between business, civil society, government. It spurs networks of expertise, so universities get on board through things like the Sustainable Development Goals, and it's just a really nice to-do list. It's got nice 17 pretty little icons that everybody can get excited about. So they have actually done a first stab at how each country performs against the SDGs, called the SDG Index. And I have to say here that I am not a fan of the SDG Index, because I think that some of the things that are in the index really don't measure the things that you want to measure. But it's a nice little chart, and you can look at it, and you can then start to have a conversation about whether it's really representative or not. And what you can see is that New Zealand does really quite well in, New Zealand does really quite well in terms of the goals on the right-hand side, and they're most of the sort of social goals, the ones about poverty and hunger and health and education, and then does less well once you get round to the right-hand side about things like life on land, life underwater, climate change, and things like that. So how does that compare to other countries? Australia's picture is very similar. Sweden are probably the best in terms of being able to have a sort of uniform picture, but even they can't rest on their laurels. If you look at the US, even more skewed, and that left-hand side now virtually disappears in terms of their action on climate change and the environment. And this was pre-Trump, I have to say, so you can draw your own conclusions as to what that might be in 3 years from now. And then you look at a developing country, someone like Indonesia, where clearly the challenges are apparent. So even though some of the data and some of the statistics are very questionable in this index, it starts to show you that it gives you a sort of graphical representation of what you need to focus on. But a key message I'd like to get across is that the Sustainable Development Goals are interlinked. So although there are 17 goals and 169 targets, if it was only that easy, but we've looked at it and we've examined it and we've studied it, and every one of those 169 targets has an interlinkage with every other one of those 169 targets. These are just a few examples. Reduced food production due to drought, desertification, and deforestation due to climate change. Clear links between the hunger goal and the climate change goal. Equal opportunities for women leads to a more dynamic and productive workforce, providing links between gender equality and decent work and economic growth. They just go on and on and on. So why are interactions important? The UN Secretary General described the Sustainable Development Goals as an indivisible whole, but everything is siloed, for good reason. Government departments, university faculties, international organisations all sit in discipline-based silos and sectors, and that's because it makes life easy, it makes it practical, it makes things doable. You have a limited number of people you have to talk to, they all talk the same language that you do, and you can get things done. But you don't necessarily, and when you start to try to link those three pillars, it doesn't always get the right outcome. And if countries ignore the overlaps, they start to try and tick off targets one by one, they risk perverse outcomes. And that's happening at all levels, from the international level down to the local level. So at the international level, FAO says, well, we'll have the food goal. UNEP says, well, we'll have the 2 environment goals. WTO says, we'll have the economic goal. The World Energy Agency says, well, we'll have the energy goal. And they all sort of grab their goal and sort of hold it like this and say, this is our turf, you keep off. And that's exactly what you don't want to happen. And that's how we got in this mess in the first place. And just as an example of one of these perverse outcomes, if we use coal to improve energy access, that would meet Goal 7. But it would accelerate climate change and acidify the oceans, so it would undermine Goals 13 and 14, as well as damaging health from air pollution, which is Goal 3. So you have to interlink these things. And so the idea is to look for targets that incorporate multiple goals and look for the synergies, the win-wins. So energy efficiency is a win-win because it's good for industry, because it saves money, and you can invent new technology. It's good for energy because it meets the energy for all target, and it meets the climate change goals. So it's all synergistic. And there are many, many of these synergies that you can identify. You can come up with scales of the way you manage these interlinkages, because what you should do, of course, is do a full systems analysis. Try going up to your minister and saying, "Dear Minister, please do a full systems analysis before you make a decision." Yeah, right. So that we've come up with some simple tools, for a 7-point scale. Is it a +3 or is it a -3, Minister? Is it strongly reinforcing or is it really negative? So just to make you think through the interaction. There are other factors you need to think about. Is what you're doing reversible? So, for example, if you eliminate a species, it becomes extinct. You decide you've done the wrong thing, you can't go back and recreate that species. Whereas if you've got a plot of land which you're currently using for agriculture and you decide you want to use it for biofuels, and then 2 years later you decide, actually that was a bad idea, you can always put it back to agriculture again. So some things are reversible and some things are irreversible. Some things there's a direction and some things operate in both directions. So providing energy to people's homes benefits education through having light, children being able to do homework. It improves gender by women being able to work in the home at night. But improving education doesn't provide energy. So there's a one-way link between energy and education which doesn't flow back the other way. Somewhat, the video obviously got in somebody. Strength, is it a really important interaction? How certain or uncertain are we about this interaction? Is it something we know well, in which case we can be confident about the decision we make, or is it something where we're very uncertain and we need to be very careful about the decision we make? Governance. Sometimes negative interactions aren't really negative interactions, it's just poor management, just poor governance. Geography. Some actions have interlinkages in other places or countries. If we dam a river to provide water for agriculture, for irrigation, then what does that do to the community downstream that use that water for fisheries? You can have consequences in other places. Time sensitivity. Some interactions play out in real time, some have a time lag. Emissions of greenhouse gases can stay around in the atmosphere for 100 years. So when you take your consequences into account, you need to factor that in. And technology can go both ways. So these, the moving up and down this sort of 7-point scale is not fixed because technology can actually open up opportunities that were not there before. So renewable energy provides new options of how we meet the energy for all goal. But equally, technology can not necessarily be a good thing. It can actually go the other way. The fact that we all have to change our mobile phones every 10 minutes means that we're using resources that perhaps we don't need to, and that we didn't, of course, use in the past. So all this says is, you really need to think about these interlinkages when you start to implement the Sustainable Development Goals. And of course, not every country can do everything all at once, and so countries are going to have to prioritize, reflecting on the national context of the Sustainable Development Goals. I don't think Nepal is going to have a great deal of effort focused on life underwater, for example. So you need to prioritize, but it's not okay to prioritize on the basis of what is easy or achievable, which is a real temptation. It's not okay to prioritize just and report on what will make you look good. And it's not okay to ignore the implications of action on your priorities or other Sustainable Development Goals. So in summary, you must take into account the interlinkages when taking action on the Sustainable Development Goals. I hope you've heard that message loud and clear now. You must take into account interlinkages when you start to take action on the Sustainable Development Goals. And you can probably figure out what the third one is. I really want to push this point home. You must take into account interlinkages when you take action on the Sustainable Development Goals, which I hope we all do. Thank you.